sorry, 6x, thank you. 6x, distracted there. 6x, and then 2 minus 1 is 1. Yeah, and then minus 0. So the second derivative is just 6x here. Right? So here's our original function. Here's our first derivative, and here's our second derivative. Okay? So we got to think back. Okay? The critical numbers here are plus or minus 2. You can think of those as critical numbers. And so we want to find out if these represent local max or min. So what we do is f double prime evaluated at, let's pick one, minus 2, and that's going to be 6 times negative 2, and that's going to give us a negative 12. So what we focus on here is whether it's positive or negative. So if the second derivative has a negative value, that means it's in the negative interval, which means it's concave down, right? And therefore, this negative 2 is going to represent a local what? Local maximum, okay, at x equals negative 2. And you should, we'll just do at x equals, you should label it as a point, so you plug x in there and x in there to get your y. So at the point, but it's fine, x equals negative 2, that's good for now. And then we also do f double prime of positive 2. And of course that's 6 times positive 2, which is a positive 12. And we have a local minimum at x equals 2. Okay? Capiche? Make a sensei? Alright, so, not real difficult, I guess, compared to sign analysis, but what would we have to do for sign analysis? We'd have to take this, we'd have to factor it, which gives you 3, x squared minus 4, right? You'd have to label those, put those, some more here. This is 3, x plus 2, x minus 2. So you got to factor all that. Then you got to put those factors on the side of the elongated L. And then you got to do your 0, right? 0, and then you got minus and plus and everything else. So, find out what the values are. This saves us a lot of time, doesn't it? Okay? Am I making my point? Am I convincing you this is a good thing? Sort of? You guys are real docile today. This stuff is just taking you back, eh? It's just like so. Takes your breath away. It's so amazing. Okay, got it. Awesome. Okay, so obviously there will be some more difficult questions. There'll be difficult questions. What will be more difficult? Well, maybe finding the second derivative. The second derivative is not going to be just nice and easy like this all the time. Maybe there'll be more critical numbers. I don't know. One thing you need to consider. Oh, just a heads up. Okay, if your f double prime of x is like negative 24, something like that. If it's a constant, that means it's concave down all the time. So if you have a critical number equaling, 5, well, it's concave down all the time. So 5 is going to be a local max, and you're only going to have one local max, right? And if you have a parabola, okay, a quadratic, your second derivative is going to be a constant, because a quadratic only has one concavity over the entire domain. All right? Questions? Okay, there's good news and bad news. This is the last piece of the puzzle for curve sketching. That's for drawing a curve given a big, long polynomial function or rational function or whatever. You have enough tools to sketch a pretty accurate curve without graphing it on the calculator. But intercepts, you'll know intervals of increase and decrease, you know where your local max and mins are, you know where the concavity and the inflection points are, and you can pretty easily now find those local max and mins with this second derivative test. So you put all that together, you're going to be able to sketch a curve real nice and efficient. Okay? Good job.